Okay. So now we do the literature reviews and surveys, and we are using the digital resources for doing that review also. Okay. Then this is very interesting part, that is collaboration and communication. Okay, collaboration and communication is a crucial component of effective research methodologies, enabling researchers to work together, exchange ideas, share resources, and achieve common research goals. Okay, so there are different types of collaborations are there: interdisciplinary collaboration, intradisciplinary collaboration, international collaboration, interinstitutional collaboration. Involves researchers from different disciplines working together to address complex research questions that require diverse expertise. Okay, so for example, I did a research on a chemical perfume and scent, right, on a perfume and scent. So I need to store the chemical equations into the system. Now I need a interdisciplinary collaboration, because I need someone who knows about the chemical equations, chemical formulas for this scent and perfumes. We are using the fragmentations, right? For that, we are using some chemicals. This involves a very big equations. Okay, so to understand it and to work on it, I need a specialist in chemistry, and the one who is working on to store the data, collect the data, and to analyze the data for that, right? I'm doing a project. Okay, and I need to show the web security also. So here I need interdisciplinary collaborations, so chemistry and an IT. Okay. So the same way, intradisciplinary. So within the day, same discipline to pool resources, share data, and leverage specialized knowledge. Say for example, I am creating an application, and this application should be hosted in AWS, right? So AWS is a intradiscipline which is run in a separate environment. Okay, and I'm having the applications. I need to up the application in an AWS cloud platform. So this is interdisciplinary collaboration. I know Java, but I don't know AWS. So I'm integrating with a team, and I am uploading my application in an AWS cloud platform. That is intradisciplinary collaboration. International collaborations, which involves different countries or region working together to bring the diverse perceptions and resources to research projects. And interinstitutional collaborations between researchers from different institutions or same universities. Okay, that comes under collaboration and communication. Under this collaboration and communication, we have the virtual collaboration tools. So virtual means, so no need to be in person. We have to virtually collaborate with the remote team members and facilitate communication, project management, and sharing of resources across different location is possible through this virtual collaboration. So Slack, Microsoft Teams, Zoom, Google Meet, we are using it for collaborator. So Slack is nothing but real-time messaging, file sharing, and collaborate channels. Whereas Microsoft Teams, integrated platform for chat, video, conference, and file sharing, and collaborate with the Office 365 integration. Zoom is so now we are doing it, right. Video conferencing, webinars, virtual meetings, rooms, and screen sharing and recording features. So Google Meet, again video conferencing tools integrated with Google Workshops. Okay, so these are some virtual collaboration tools we are having. Okay, and project management softwares like Trello, Asana, Basecamp, Monday.com can be used for project management. While Trello is a Kanban style project management tool for organizing tasks, workflows, and deadlines, whereas Asana gives project planning, collaboration, and team communication features. Basecamp, on other hand, with to-do list, file sharing, and message boards, or the Monday.com operate a system for teams to plan, track, and collaborate on project with a customized workflow. Okay, so these are the tools we are using for project management software. So benefits, as usual, we work as a team, real-time updates we can get, improve project management, we can share files, data, everything. Whereas the challenges are over reliance on technology. So if technology is not there, right, if there is failure in Slack or Teams on a particular day, right, then the entire collaboration and communication will collide or collapse. Okay, so and potential communication should be overloaded. So when we are doing the work, we need to communicate it in a very proper way, as it's a real time communications, right? We need to be very careful on giving the messages and the response. Okay, so that's all about communication and collaboration. And the next topic is publishing and dissemination. Okay, now we reviewed it, we collaborated, we shared the files, we corrected it, everything we did it. Now it's time for publishing in the platform. So we need to publish. Okay, yeah, it's a crucial phase in the research process, enabling researchers to share the findings of an academic community, policymakers, industry professionals, and public. Because if they share their researches, right, then it can be enhanced or expanded based on the need. Okay, so we need to publish the our research. Okay, first is there are research publications are there, different publications. One is journal articles. Okay, journal articles means peer reviewed the articles and published the article in an academic journals. Okay, and it is the primary mode of scholarly communication. So this is the primary mode. Okay, no need to write the book and all on the first piece. Okay, first do a paper publications in a journal as an article, and conference paper, attend some conference. So in the conference, right, when our paper is presented and published in conference proceedings, in a conference paper, right, a conference book, that is enough. Then the third one is the books and monographs. So comprehensive works providing in-depth coverage. If you get an in-depth coverage on your research topic, and if you are having more data to present, right, then you can go with this books and monographs. Thesis and dissertations. Original research submitted a part of academic degree after available through institutional repositories. So finally, you get a thesis. You submit the thesis, right? You will get a degree also. That is, you get a PhD. And the publishing process. First, you need to for publishing a paper, right? First, what you need to do first is you need to submit the paper to an publisher. Okay, that is the first step, submission of journals. Okay, then it should be peer review. So someone has to review a research paper, and they will give a response, right, with the feedback. Then you need to do a revision. Revision is you are going to get the feedback. After getting the based on the feedback and addressing comments and suggestions, you are going to revise your paper. After that, it will be accepted and it should be published in a journal. So if you are publishing your paper in any journal, is this the right way to do it? No, you need to first identify the right journal. So is that having a scope and it is fit for you, right? That you need to identify. Then the impact factor. So how much impact factor it is having, that is a citation metrics, right? So based on that, right, you need to push it. Open access options. Evaluate journals offering open access publications. Maximize visibility and accessibility of your research. Publication fees. Then you need to check the publication fees. And another way is you need to publish the paper in an open access. Open access means anyone can view your research papers. Okay, it's publicly you are introducing the research. So this helps in increase accessibility, visibility, and the comments, the feedbacks you are getting, right? That will be very high. Okay, and finally, you need to what it is, share preprints. Okay, uh, preprints, conference presentations, publications through academic social networks like ResearchGate, academia.edu, and LinkedIn. You can post your papers. Okay. And then ethical consideration should be taken care while you are sharing the data in an open platform. Okay. And for this, right, you need to plan early. Okay. So uh, before what it is, you need, if you are starting with the research, right, after starting with the research, you need to just plan your publications. Okay. How you are going to do, who is your target audience, and whether you are using multimedia formats or you are doing any metrics or evaluations like that, you need to address, you need to find it, and then you need to find the right journal or the right place to publish your papers. Okay. That is the main thing in digital publishing platforms and preprint servers. Okay. Digital publishing platforms are there, right, has revolutionized how researchers and authors disseminate their work of offering accessibility, visibility, flexibility in sharing research findings. These platforms vary in terms of features, audience, reach, and publication mode. Okay. The Public Library of Science, PLOS, a non-profit publisher with a suite of open access journals covering various disciplines in science, medicine, and biology. Biomed Center, Frontiers. So these are some publishers which help us in getting the um, our paper published in a right way. Okay. So these are some digital publishing platforms, and then we have pre-print servers. So we have ARXIV. Okay, it's a repository for preprints in physics, maths, computer science, quantitative biology, quantitative finance, and statistics. So only these papers are considered on ARXIV. Like the same way, BioRxiv, it's only for preprint server for biology. SSRN is a social science research network, preprint repository for social science and humanities, including economics, law, and management. Okay. Social science research network. The platforms like ARXIV, Bio or XIV allow the dissemination of research findings before formal review. Okay. And institutional repositories are also there. So what we are saying is preprint servers, right? In that institutional repositories, which is for particular institutions, right? Like Digital Common, D space, e-prints are some of the institutional repositories. Self-publishing platforms are also there. So you can publish your paper by yourself in Amazon Kindle Direct Publishing. KDP. Okay, search in the internet and you can use this for publishing, self-publishing, Smashwords, Lulu, right? These are self-publishing platforms. Academic social networks, right? ResearchGate, academia.edu, Mendeley, right? These are the academic social networks. So via these social networks also we can share research papers, monitor the impacts, metrics, connecting with researchers, anything we can do via this academic social networks. And blogging and personal websites. So we can have our personal websites, or you can blog your research in some blogging websites like WordPress, Medium, right? You can do it, and you can make your publishing in a wider range. So the benefits are increased visibility and faster dissemination of research. Okay. But the challenges is quality. So if you are not reviewing our thesis, peer review, do that peer review. If you don't analyze it, right, then it will really, there is no quality on it, and there is no one to control the quality of these papers also, right? If it is published in a common platforms. Okay. So that is the challenge. Okay. Then the most interesting and super topic is remote sensing and GIS. Okay, what is remote sensing? Remote sensing involves acquiring information about the Earth's surface without direct physical contact, typically using sensors mounted on satellites, aircrafts, drones, or ground-based platforms. It allows researchers to gather data across large areas and different wavelength of the electromagnetic spectrum, include visible, infrared, and microwave. Okay, types of remote sensing. So remote sensing is having different types. One is passive remote sensing and another one is active remote sensing. So passive is sensors detect natural radiations, okay, that is emitted or reflected by an object. Active remote sensing is sensor emitted energy like a radar, LIDAR, right? We can measure the wavelength. Like when we are using in an aircraft, right? Then it is active remote sensing. Okay, applications of remote sensing wherever we are using these remote sensing is environmental monitoring for this climatic changes and all those, right? For that we are using agriculture, we are using urban planning, natural resource management also we are using it. Graphical information system, GIS. Okay, this graphical information system we mainly used in our Google Map, right? So we are using it. We are analyzing the data, interpret and visualize the spatial patterns and relationships. Okay, so the components is data. So we are getting the spatial data, attributes, data layer, and we are using softwares. Okay, for visualizing. So some softwares like ARCGIS, QGIS, ENVA, okay, which I listed in that presentation, right? These software tools we are using for this GIS. Okay, then hardware also we are in need to process and store the data, and people. Okay, we need the researchers to do the analysis on the data. And where we are using this GIS means mapping and cartography, spatial analysis, decision support system, environmental mapping, public health. Okay, and this GIS software, right? We are used in so many ways. Okay, one is desktop. In desktop, we are using by installing the application and we are using it. In web, so we are opening that web page and we are using it. Then in mobile, geospatial data analysis and visualization tools, and then 3D. GIS and visualization tools we are using. So just I am telling the names which we are using in our desktop GIS software. Okay, this is ESRIARCGIS. Okay, this we can install in it on our local desktop. Okay, and we can use this application for mapping, spatial analysis, data management, visualization. Okay, this includes ArcMap. Now transition to ARCGIS Pro. Okay, then QGIS is Quantum GIS, open source desktop GIS. It's an open source, you can download it for free. It supports a wide range of data formats and is customizable, highly customizable. Then Glass GIS, Map Info Professional. Okay, these are some applications. Whereas in web GIS platforms, we are using this ESRI, ARCGIS in online. Okay, Google Earth Engine, Mapbox, Carto, we are using it in online. And then a mobile GIS application. Mobile, we are having a collector for ARCGIS, Fulcrum, QField, like that. Geospatial data analysis, which involved NVGDAL, Geoda. Okay. And then 3D GIS and visualization tools are also available, which includes a City Engine, SketchUp, Blender, like that. Okay. Apart from that, we are having remote sensing technologies also. Remote sensing technologies is nothing but satellites, aircrafts, and drones. Through via satellites, Landsat, Sentinel series, MODIS. MODIS means moderate resolution images spectroradiometer. Okay, aircrafts, high spatial resolution and the specialized sensing for that. From aircraft, we are doing it. Drones, then provide a flexibility for similar scale and targeted data collection mission. Okay, so these are the benefits are spatial analysis we can do, Yes, accessing the real-time data, we can easily access the real-time data, and it is very useful. And the finally, the challenges, the main challenges is the hardware we cannot able to purchase as easy because it's a half high cost, and the technical expertise required for analyzing this data. That's another big challenge we are having. And experimental and stimulation tools. Okay, so we analyze the data, and we have this tools, spatial data also we can able to analyze. Now, experimental and simulation tools. So there are two types of experimental and simulation tools are there. Okay, this helps in testing hypothesis, stimulating the real world scenarios, and the tools are really depend on field of study. Okay, in actually, when we look into this simulation and modeling tools, right, we are having finite element analysis software. Okay, finite element analysis software, that is FEA. This tools like ANSYS, Abacus, and COMMOL, it's like it transfers. That is, it's not transfers for simulating structural mechanics. Okay, for that we are using this FEA software. Then computational fluid dynamics, CFD software. Okay, then discrete event simulation software. Tools like Arena, Simino, and AnyLogic are used for this discrete event simulation software. Agent-based modeling. Okay. Okay. Now we are talking about computer simulation. So, what is actually computer simulations? Okay, that's the main thing, right? So, simulating a particular act. Okay, that is simulating. Like, I want to be a pilot. I want to uh, fly an aeroplane. Okay, but I cannot take the aeroplane directly and I cannot fly. Okay, I need to have a training in a simulation environment. Okay, that is what we call as simulation. The same way, modeling. So, modeling is see, I'm have a model of data. Using that model data, right? I'm creating a theory. Say, for example, I want to do a time travel. Okay, or I want to do a research on God particle. Okay, then what I have to do is I need to go for this model. We have to take a sample model of data and we need to work on it and we need to come up with a solution. The tools and softwares which we are used to in modeling, right, that is MATLAB, R programming, Python programming, Simulink are the programs we are using it. Okay, this computer simulation, right, after that we are having virtual and augmented reality. Okay, virtual reality is, as I said, if I want to run an flight aircraft, right, then I have a virtual environment. Virtual means I really don't have that environment, but we are having that environment. Okay, virtual environment, and in that virtual environment I am going to practice to fly an aeroplane. Okay, that is virtual reality. Now you, I hope you understand that when we are go to some PlayStation, right, we are given with an scooter and a road. Okay, but actually the road is not there, but whenever you are turning that scooter here and there, and when you are raising the accelerator, right, it seems that you are running on that road which is stimulated, right? That is virtual reality. And we have a screen like this, right? And you, if you put it that glass over you, the virtual reality glasses, then you feel like you are in a mountain or you are in an icy area, but actually you are not. Okay, that is called as virtual reality. Whereas on the other hand, augmented reality is nothing but I want to wear a glass. Okay, but I don't know whether it suits me or not. Okay, so what I do is, in an virtually you can wear a specs in an application. Okay, if you put that you take a picture of you, and if you put a specs on your glasses on your eyes, right? If it fits and if it looks cool, then you can buy that a particular glasses. So that is the concept of augmented reality. Okay, I want to check an object. Okay, whether it is uh, the quality is good or not. Okay, without touching that object. Then how can I do? Then I can take a pictures of that object, and I am comparing that image of an object with the original image of an object, and I am comparing it. So this is augmented reality. So there are type of virtual reality. One is immersive virtual reality, 360-degree video. And this applications, right, where we are using this virtual reality is gaming and entertainment, education and training. We are using it, healthcare, architecture and design. So you want to build an house, right? So you can use this virtual reality and you can build it, and you can view the house image, okay, before building itself. And in augmentation reality, there are three types of augmentation reality: marker based AR, markerless AR, project based AR. Okay, these are the three types of AR, and where we are using it in retail and marketing, education, navigation and wayfinding, manufacture and maintenance. So we are using augmented reality in these areas for healthcare exam. And okay, it has its own advantages and disadvantages of this augmented reality. And so one is immersive experience. Okay, if I want to fly an aeroplane, then I get an experience, right? Through virtual, I can able to get an experience. Visualization, I can visualize it as real platform, innovative. But the main problem is hardware requirement. You need to be user comfort, and privacy and security is needed, and someone has to monitor it, and it is very expensive to maintain it. Okay, so these are the disadvantages of this experimental and simulation tools. Okay, just have a take of break for 5 minutes, and then we will connect on this ethical consideration and data security.